So in previous videos, we've discussed linear functions, and in the last video in this series, I talked about exponential, logarithmic, and quadratic functions. So next I want to talk about how we can model data, and in particular, looking at linear models, exponential models, logarithmic models, and quadratic models, and see how these different options can fit data. So when I'm saying modeling data, let's say that we have a data set, and I'm just going to use a really small data set of x and y values. Let's say we have 0, 5, 1, 3, 2, 1, 3, -1, and 4, -3. So these are some observations where I have a x variable paired with a y variable. So to look at the behavior of these data points, I can plot the points. This is making a scatter plot. So I have the point 0, 5, 1, 2, 3, 4, 5. Actually, let me go ahead and just add some marks here. 2, 3, 4, 1, -2, -3, -4. And so I have the point 0, 5, 1, 3, 2, 1, 3, -1, and 4, -1, -2, -3. Sorry, I put that point at 0, 0. It's supposed to be at 0, 5. 1, 2, 3, 4. Should have been up here. So notice that these points seem to line up. And so when I say that I'm going to model, I'm going to try to choose a function with a graph that is going to come as close to these points as possible. And so in this case, a linear model is going to be able to approximate the pattern in this scatter plot. Namely, if I can just find the equation for a line, for this line in particular, I actually may pass through every single one of my data points. Now, not all models are going to have a perfect fit. Sometimes you're just going to be able to come close to your data points, but we want to choose a model that comes the closest to all of our data points. So in this case, it seems like a linear model would be appropriate. Let's look at another example of a small data set, and where we'll first look at the scatter plot and then see if we can guess which type of model would be best for approximating the data. So in the second data set, I'm going to have the values 0, -4, 1, -1, 2, 0, 3, -1, and 4, -4. And once again, I will sketch a pair of an x and y axis and mark off some values. 1, 2, 3, 4, 5, -1, -2, -3, -4, and so forth. And let's add these values. So I have 0, -4, 1, 2, 3, 4. So that is the point right here. 1, -1, and 2, 0. I have 3, -1, and 4, -4. So it looks like what I'm seeing is a parabola. And so I think that a model that would be appropriate for this would be a quadratic model. And let's do one more. Let's see, I'll start with the table of values for my data set, 0, 1, 2, 3, and 4. And for the y values, I have 4, 5, 7, 11, 19. So my y values go pretty high, so I want to actually draw a little bit bigger graph. And I'm going to just mark these off at 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. That way I'll be able to plot this point 4, 19, and this will be 0. And I'll start with 0 here, and 1, 2, 3, 4, 5. That's my x values. These are my y values. And let's plot these points. I have the point 0, 4. That's here. 1, 5 will be in between these two lines. 2, 7, 3, 11, and then 4, 19. And so it looks like these have a curve that goes up. Now, it can be difficult to know whether it's going to be better to use a exponential or a quadratic. This looks like it could be the right half of a parabola. So, we don't know for sure if this would continue on the other side like this, in which case it would be a parabola, or if it just continues to decrease like this, in which case it would be exponential. Another clue can be how quickly this increases. So I'll show you in your calculator how you can determine which is better. Should we use y equals ax squared plus bx plus c? Or should we use y equals some base to a power? So I'm going to go back to our previous examples and show you how to use your calculator to determine a model. So let's see. The first thing I want to do is to input the data in a table. So I'm going to go to my stat menu and I'll edit. I'm going to just clear what I have in here. And I'll put in my x values 0, 1, 2, 3, 4. And for the y values, I've got 5, 3, 1, -1, -3. So let's see, those are my x, my y. So next I'll go to my stat menu. This is a calculation, and I can. There are different options here. Number 4, for instance, this is a linear regression. So a regression is the line, the model that approximates our data. So if I think a linear model is appropriate, I might choose a linear regression. There's also quadratic regression, that's option 5. Exponential regression is option 0, and logistic regression is option B. So I think that a linear model is appropriate here. Let's see if we can get that. Option number 4, linear regression. I'll hit enter, and I need to add some arguments. Now, some of you may have prompts on your calculator, and since I don't, I'm going to use L1 and L2. I'm using the second key to select L1, which is in light blue above the 1 key, and that's a comma separated. This says where my x values are, and this is where my y values are. And I'll hit enter. And so this is the general form of the model, y equals ax plus b. The a value is -2, and the y value is, or the b value is 5. So here, the model is y equals -2x plus 5. Let's look at the next example where we had a quadratic. So here I'm going to go back to my stat menu, edit my table, and I'll change these. Well, I still have 0, 1, 2, 3, 4, but I need to change these to -4, -1, 0, -1, and -4. -4. And let's, oh, by the way, if you want to, I'm sorry, that's the wrong thing I wanted to do. I wanted to go to stat plot. I can turn my plot on and select the scatter plot with my x values in L1 and my y values in L2, and then look at this and notice that my calculator will, oh, I'm sorry, there's some extra information here. I'll wait for this to end and then I'm going to turn off these other graphs. Let me just clear this out. So I'm going to go back to my stat plot and zoom, option 9. And so now we see a scatter plot in my calculator. So now, as far as finding the model, again, I will go to Stat, Calculations, and this time I think a quadratic model is going to work, so I'm going to choose option 5. And again, since I don't have the prompts turned on in my calculator, I'll have to say L1, comma, L2. And so here's the general form of the model, ax squared plus bx plus c. But the particular values that are going to work best here are -1, 4, and -4. In other words, y equals -1x squared plus 4x and then -4. The 1 here, I don't have to write that. I could just say y equals -x squared plus 4x minus 4. And let's do the last one here. Let's see, I'll go back to stat, edit my table. I still have 0, 1, 2, 3, 4. I'm going to change these to 4, 5, 7, 11, and 19. And then I will look at the scatter plot by zoom, option 9. So notice this looks really similar to what I drew by hand. And now let's look at the different models. So stat, calculation. So first I'm going to do the quadratic, so option 5, and say that my data is in list 1 and list 2. So that model would be y equals, I'm going to round to 4 decimal places, 1.1429x squared minus 0.9714x plus, oops, I'm running out of room here, 4.2857. So that would be the quadratic. And then let's look at the exponential. I'll go back to stat, calc, and exponential model is option 0. And again, I'm in list 1 and list 2. And so this would be y equals, the a value is 3.5817 times b is 1.4777, and that's to the x power. I want to just put parentheses around this. So I mentioned before that you are in our basic exponential, it just looks like b to the x. Now you can have another multiple here, and you could even add on a value. So some other options, this could be a times b to the x, and then you could even have a plus some constant amount. So this was just the simplest form, but it is possible to have a multiple of the exponential and adding on a constant at the end. So in this case, I have the multiple of this exponential expression. So let's look at both of these. I'm going to turn on my, look at the graph by going to my y equals menu. I'm going to add both of these in, 1.1429 x squared minus 0.9714 times x plus 4.2857. So that's the quadratic. And then let's go down and add an exponential. That'd be 3.5817 times 1.4777, and then I'll raise this to a power of x, and then close my parentheses. So let's go back to our scatter plot, and then, so the first graph that we're seeing, this is the quadratic. The next graph that we're seeing is the exponential. So it looks like either of these would be a fairly good fit. So I think that the choice here would be somewhat subjective as far as which would be the better option. To make a more informed decision, in this case, I would want to see some more data to look at the behavior that's outside this viewing window. Right now, though, it looks to me like the quadratic is the better choice. But again, with some more data, we might choose the exponential. Again, it just kind of depends on what is happening as we move. If we could have some observations that were have some negative values of x, if that's even possible, or what's happening as we move further and further out at our x values. So in the next video, I'll show you some application problems, and so I hope you'll join me.